Hey everyone, I'm going to be showing you guys how to do a integral with partial fractions problem and how to convert this and simplify it. So this is a problem that is the hardest it will get up to on the AP Calc AB test, so it doesn't get as hard as this on that test, but for BC level it will get harder. And in fact, in colleges, some of them start using complex number integrals with partial fractions, and yeah, that's pretty complicated. But anyways, we have x with 3 degrees. So why don't we factor out x first? I'm going to ignore the integral sign later and then come back to it. So x squared plus x minus 2 equals x plus 2 x minus 1. Yeah, I just factored it out. Now that I have 3 components, let's label these A, B, and C. Actually, let's not label it like that because we're going to use it for the numerator components. Plus B, x plus 2 plus C, x minus 1. Okay, now that we have this equation, there are certain values for A, B, and C that will make this expression equal to 1 over x to the third plus x2 minus 2x, and we just have to find the values. So looking at this, you can already tell they're probably going to have to be 3 equations, and luckily we have 3 components, meaning we probably will be able to get those 3 equations, because if there's 3 degrees and the numerator only has 1, that means that we would be able to make a lot of expressions equal 0, and I will show you right now. So I'm gonna start by factoring it out. B x minus 1 plus C x plus 2. Okay, so I just multiplied it out. Now after you keep multiplying, we have ax squared plus ax minus 2a plus bx squared minus bx plus cx squared plus 2c 2cx. Okay, and with the skill that I've taught you before in the previous partial fraction videos, you can just add up these with the same x to the same degree, which is to the second degree, plus a minus b plus 2c x minus 2a. So I just moved around the terms and factored out like terms. Now looking back to the problem, we have on the numerator we only have a constant 1. There is no x squared, there is no x, so these will have to equal 0. A minus b plus 2c equals 0. Minus 2a. Now, minus 2a, that will equal the constant, which is 1. And we can simplify that to a equals negative 1/2. Now, we already have one of the terms down, and we have 3 equations, which makes it really easy. We have 2 equations left, so let's eliminate b by adding the 2 equations together. 2a plus 3c equals 0. And we know what a is, so we just plug in negative 1/2 for a. Negative 1 plus 3c equals 0. Next step, 3c equals negative 1 divided by 3. So c equals this. Oops, this is actually a positive because I added 1 to both sides, so that's a positive. So equals 1/3. Now we have another variable covered. And by plugging these two values inside this equation, -1/2 plus 1/3 plus b equals 0, and just make it 6, so it's 3/6, 2/6, so it must equal 1/6. We're almost done. Now for the integral part. Since we know all three values, let's just write it down here for convenience. B equals 1/6, C equals 1/3. Okay. Got a cleaner board. So we can split the integral into these three components. -1/2 x plus 1/6 x minus x plus 2 plus 1/3 x minus 1. With the constant multiple rule plus the rule which says you can split these equations if it's the addition sign, we will do that. So -1/2 we'll have 1/x plus 1/6 integral dx. Always forget to put the dx. Yeah. 1/6 1/x plus 2 dx plus 1/3 I know it's kind of messy. 1/3 integral 1/x minus 1 dx. Okay, now that we have these values, we can just use the rule that says if we have du over u, it equals ln absolute value of u plus a constant. Integrals always have to add a constant. So -1/2 ln x plus 1/6 ln x plus 2 plus 1/3 x minus 1. And we are complete. Thank you for watching.